We're going to begin this chapter by taking a look at what's called periodic behavior. So periodic behavior is something that repeats itself over and over and over again. So there are many things that have kind of periodic behavior. If we take a look at daylight over the course of many years, how much daylight there is during a day, that looks like what we call a periodic function. It creates a graph that kind of repeats itself. Excuse me. Moon cycles, that sort of thing. Gravity, tides, it's all kind of represents what we call periodic behavior. But let's take a look at what these graphs could look like. So periodic motion is when a graph is exactly repeated over and over again. It's what we call a periodic graph. So if we take a look at some of these graphs, it can give us some examples. So if I take a look at this first graph, we can see we start high, then we go low, then we go back high, then low, then high, and we can see that it's repeating itself exactly over and over again. So this one would definitely be periodic. As we look to this next graph, it looks like this wave is kind of happening, and it reaches the same heights, the same maximums, and the same minimums over and over again. So this would also be considered periodic. Here we have this little niche inside, then it goes up, and then over, then down, and then over, then up, then over, and it is repeating itself again and again and again. If I actually kind of draw a line right there, it looks like this is what is repeating over and over again. There's one there, and then there's another one here, exactly the same, and then they're creating the next one. So this is definitely periodic. And this one, though, it is like this wave is going, it's not reaching the same maximums and minimums. So this would be not periodic because it is not exactly the same. So that exactly has to happen. And in this case, it doesn't. So that is not periodic. All right, so just a few definitions. So you may want to pause here to get this copied down. So we have maximums are maximum height. Minimums are the lowest height. A cycle is one complete pattern of a periodic function. So a cycle is kind of how long it takes to start and stop to create just one of the periodic functions. The period is the horizontal length of one cycle of a periodic function. So the period is the length of time, kind of, if we were talking about time, but the length to create just one cycle. And then the amplitude. So your amplitude, this is probably new. Your amplitude is half of the distance between the maximum and the minimum value. So if I was looking at this, we have a maximum at 9 and we have a minimum at 3. So half the distance between would have to be right here. Oh, that's not showing up very well. Let me do this in a highlighter. Right here at 6. So that would be where the halfway mark is. So right here at 6, which means I have an amplitude. So it's a length. So it's the length between 6 and 9 or the length between 6 and 3. It doesn't matter. Either way, we can say our amplitude in this case is 3 units. Okay, because we can see that distance that's happening. So it's your vertical distance. It's half the distance between your max and your min. Since it is half the distance between your max and your min, what we can do to figure it out if you had, let's say, messy numbers on your graph is you could just take your max minus your min and divide it by 2. That will also give you your amplitude. So that would be 9 minus 3 divided by 2, which is 6 divided by 2, which is 3. So we can see we get the same answer. Most of the time it's just as easy just to look at your graph and be able to pull it out, but if not, max and min, this gives you your amplitude. Okay, so let's take a look at just a couple of examples. State the minimum, the maximum, the period, and the amplitude of the function shown. So we're going to take a look at this first one right here, and our min is our our min is our lowest point. So my min in this case, be my lowest point, be right here looks like is the lowest point. I go across, and so that would be at 2. And my max, which is my highest point, looks like it's up here, which is at 8. The period, remember, is the length of time that it takes for one cycle to occur. So you gotta find a cycle. You gotta pick a starting point and pick an ending point. So let's say I was gonna look at this cycle right here. It goes up, then over, then up, then down, and then it starts to repeat itself. So I'm gonna pick that to be my cycle. Maybe you pick something a little bit different, so that's okay. And that starts at 4 and it ends at 9, which means my period is 5. It takes 5 units in order for that cycle to occur. And then lastly is my amplitude. So remember, your amplitude is your max minus your min divided by 2, which is 6/2, which equals 3. Another way to do that is just go halfway in between 8 and 2. Halfway in between 8 and 2 is right here at 5. So I can go right here at 5. And then I can just measure out the difference between 8 and 5. Or I can measure out the difference between 5 and 2. That would also give it. Okay, let's try another one. So here's the second one. There we go. Okay, so taking a look at this one, same thing. I'm going to want to figure out my min is at 2, and my max, which is my highest, is at 9, and my period. So I'm going to start here, I think. I think that's a good place to start. And then it goes up and it makes a strange kind of shape on the side, and then it goes down. So it starts at 5 and it goes to 13. So 13 minus 5, which is 8. So my period is 8. And then, of course, my amplitude. I can find my halfway mark in between 9 and 2, but I think it might be easier this time to go 9 minus 2 divided by 2. Which is 7/2, which is 3.5. So it has an amplitude of 3.5. Okay, last one. If you want to give this one a try, just a sec. I'm going to actually cut. Let's put this on a new page so that we can actually see it. There we go. Okay, so here we are. My min is my lowest number. It's right there at 4. My max is my highest number. It's right up here at 8. My period, I think I'm going to, now this one's weird, so pay attention here. So it goes down, and then this slant is only 2 over, and then it goes up and then down. But then this slant is 3 over, and then it goes up and down, and the slant is only 2 over, and then up and down, and then the slant looks like it's 3 over. So I'm actually going to pick this part right here to be my starting, and this right here to be my ending, because we have to include both sections of it. Because these two are not exactly the same, right? So it looks like this whole thing is what's being repeated over and over and over again. Okay, so 15 minus 4, which is 11. And then my amplitude, I can go halfway in between 4 and 8. But I'm just going to go 8 minus 4 divided by 2, which is 4/2, which is 2. So it has an amplitude of 2. All right. So let's talk about a few applications then. The elevator of an apartment building is broken. It starts on the 5th floor, and then it goes to the basement, and then back up again, but it never stopping on any floor. It continues to move between floors, taking 2 seconds between each floor. Graph the motion of the elevator. All right, so over here, we're going to have floors. Now we got to make a few assumptions. I'm going to have the basement equal floor 0. Okay, so I guess floor 1 would be like the main floor, and on from there. It starts on 5, then goes back up to the basement never. So it only goes up to 5. So 1, 2, 3, 4, and 5. And then it takes 2 seconds between each floor. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Okay, and this is in seconds. So if I was going to graph this, it's starting on the 5th floor, and then 2 seconds later it's on the 4th, and then 2 seconds after that it's on the 3rd, and then 2 seconds after that it's on the 2nd, 2 seconds after that it's on the 1st, and then it's in the basement after 10 seconds, and then it's going to go back up. And it never stops, just keeps going and going. Nobody gets on or off or anything like that. Okay, so this is what we get then if we graphed it. Then we start going down from there. All right, so next question. So what's the period of the motion? So the period, remember, is that length of time it takes till it starts repeating. So it goes down and it goes back up, and then it would start repeating itself again. So we can see from our graph that it would be 20 seconds is the period. And then how long would it take to make 20 cycles? Well, if it takes 20 seconds to make one cycle, 20 seconds for one cycle, then if we want 20 cycles, we would have to multiply that by 20, which would give us 400 seconds, which we could convert that, right, into minutes and so on. So 400 divided by 60 gives me 6 minutes and 40 seconds left over. 6 minutes and 40 seconds. And then our last question here is what floor is this going to be on after 1 hour? So first thing I want to do is figure out, well, like in terms of seconds, because this is all in seconds, I want to figure out like how many seconds is 1 hour. So 1 hour is equal to 60 minutes, and 60 minutes times 60 seconds, so 3,600 seconds. Now, it takes 20 seconds, so it starts on 5, and then it takes 20 seconds and it's back up to 5. So every 20 seconds it's back up to floor 5. So let's start by dividing this by 20 and see if it divides evenly. And it does. Okay, so 180 times this cycle is going to happen. But it's going to happen evenly, which means we're going to end up on the 5th floor at the end of a cycle. Perfect. All right, so we can see how this periodic motion, this repeating over and over again, can help us answer some of these questions, these application questions. All right, so that's all there is to periodic motion. It's just graphs that repeat themselves over and over again. In the next lesson, you're going to take a look at sine and cosine graphs, because they are graphs that create periodic motion, periodic graphs. So hopefully this gives you enough little insight as to what all that means. Thanks.